Hello everyone and welcome to Pentagon. Today I have an arithmetic problem for you. Given that 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared and so on sums up to pi squared over 6, compute the value of the expression 1 over 1 squared minus 1 over 2 squared plus 1 over 3 squared minus 1 over 4 squared plus 1 over 5 squared and so on. Please pause the video here if you'd like to try and solve this yourself. Alright, the first thing we need to do is write this expression in terms of our first expression, which equals pi squared over 6. So let's do that. The first term of both expressions is the same, it's just 1 over 1 squared. Now, the second term in our first expression is a positive 1 over 2 squared. But we need to add something here such that the values of these two terms sums to negative 1 over 2 squared. So what can we do? Well, we can subtract 2 times 1 over 2 squared. And the sum of these two terms will simplify to negative 1 over 2 squared. Alright. The third term in both expressions is also the same. It's a positive 1 over 3 squared. And now the fourth term in our first expression is 1 over 4 squared. But we need to add something again, such that the value of two terms will sum to negative 1 over 4 squared. So once again, we can subtract 2 times 1 over 4 squared. And this will continue. Alright, now when we rearrange the terms, we get 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus 1 over 5 squared, and this will continue. And in the second part of our expression, we'll have minus 2 times 1 over 2 squared minus 2 times 1 over 4 squared minus 2 times 1 over 6 squared, and so on. The first part of our expression should look familiar. We know from our first equation that this is equal to pi squared over 6. So all we need to do is find the value of this expression and add the two values together. So let's do that. We'll take our second expression, this, and what we can do first is factor out a negative 2 from the entire thing. And if we do that, we have negative 2, and in brackets, 1 over 2 squared plus 1 over 4 squared plus 1 over 6 squared plus 1 over 8 squared, and this will continue. Now we see that each denominator has an even base. So let's rewrite each base with its factors. So this expression will become -2 times 1 over, and in our denominator we have 2 squared. Now 2 can be written as 2 times 1. And we'll square that. Our next term is 1 over 4 squared. 4 can be rewritten as 2 times 2. So we'll write that in and square the whole thing. Our third term is 1 over 6 squared, and 6 can be rewritten as 2 times 3. I think you can see where I'm going with this. That's a 3. We're squaring this. And finally, our fourth term is 1 over 8 squared, which is also 1 over 2 times 4, all of that squared, and so on. Now let's expand these denominators. So this becomes -2 times 1 over, if we expand the first denominator, we get 2 squared times 1 squared plus 1 over, if we expand the second denominator, we get 2 squared times 2 squared, and if we continue through with this, we'll get plus 1 over 2 squared times 3 squared plus 1 over 2 squared times 4 squared, and so on. Now, you'll notice that each of these terms has a factor of 1 over 2 squared. So let's pull that out of the brackets. So this will become -2 times 1 over 2 squared times 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared, and so on. Well, this should look familiar. What's inside the brackets is simply equal to pi squared over 6. Wonderful, so we can make a substitution in here, and this simplifies to -2 times 1 over 2 squared, which is 4, times pi squared over 6, and this will simplify to -pi squared over 12. Alright, now we know that the value of this expression is -pi squared over 12. And now all we have to do is add these two values. So we will get pi squared over 6 minus pi squared over 12, and if we simplify that, we get our final answer, which is pi squared over 12. Thank you for watching this video. If you liked it, then please consider subscribing to our channel. Thank you all, and I will see you in the next video.